Anurag Dutta
Yes,
is
sir.
there?
Yes, sir.
Yeah,
Am I
please
audible?
share your yeah, audible, and share your presentation. 7 minutes, huh?
Hmm. Sir, is this point visible?
No, it is not visible.
Yes, yes.
Just will wait.
No, yeah,
It is
yeah, it's not.
visible. It
Is
is
it
visible.
visible? Okay, okay, fine.
Now it's okay, yes.
Huh?
So, hello everyone. This is Anurag from India, and today in the ICCIKE 2023 conference, I will be presenting the paper entitled Stellar Classification vis-a-vis Convolutional Neural Network. This is a little bit of introduction about me. I am currently an undergraduate at the Department of Computer Science and Engineering at Government College of Engineering and Textile Technology, Shriram, Calcutta, India. So, beginning with the paper presentation, this is a little bit of introduction of the work that we have put forward in this paper. It is a summary of the work basically. So, the area between the celestial bodies and beyond the Earth's surface and its atmosphere is known as space, or we could say it like it is an outer space. In addition to electromagnetic waves, there are magnetic forces, neutrinos, dust, and cosmic rays over there. There is a relatively low concentration of particles in space, the majority of which are like hydrogen and helium atoms rotating with a high velocity along a certain particular axis, which are being subjected to electromagnetic radiations. So, in this paper, what we are doing actually is we are trying to classify celestial bodies on the basis of their spectral classification, that whether glowing body or more probably a celestial body is a star or galaxy. And we will be talking about that in my next slides. So this slide is about the outer space. The radiation level from the Big Bang established a temperature of 2.7 Kelvin as a standard for the universe. It is believed that approximately half of the baryonic mass in this universe is composed of plasma. The accumulation of matter in specific regions leads to formation of astronomical objects like galaxies and stars. And these are the two celestial objects which we are targeting to classify in this paper. So, since this work is regarding stellar classification, we would hereby consider only the stars and galaxies in the outer space matrix. A star is a sort of heavenly sphere that is composed of luminous globe of plasma that is bound in place by the star's intrinsic gravity. The Sun is the astronomical body that orbits the galaxy in the opposite direction of Earth. At night, there exists a significantly large number of extraluminaries that are visible to the naked eyes, but because of the enormous distance, we can't easily classify that whether a glowing object is, let's say, a star or it may be a galaxy. So, astronomers have provided some catalog which could list every known possible stars and provide conventional designations to their stellar names. Using those lists, we can determine stellar characteristics such as mass, age, luminosity, metallicity, variance, distance, and many other characteristics with which we can classify whether this glowing object is a star or not. So, in this paper, we would make use of the convolutional neural network. Apart from the techniques which have been given by the astronomers, we would be making use of convolutional neural network. So, this slide is a little bit of introduction about what convolutional neural network is, and in the coming slides, we will be talking about the architecture of the CNN. So, a ConvNet is a type of artificial neural network that is typically utilized to analyze visual data or imagery data. Convolutional neural networks are shift invariant because of the convolutional layers or filters that slide along the input features and construct translation equivariant feature maps due to downsampling process that most convolutional neural networks perform on the inputs. These networks are not invariant to translation. This is contrary to what one may expect. This can improve imagery and video recognition, categorization, rendition support system, and many other things. This slide is about the architecture of the CNN. So CNNs are basically composed of three layers. The first being the input layer, the second being the hidden layer, and finally the output layer. Uh, Inside this layer, there exist various activation functions like ReLU, softmax, and other. Convolutional neural networks have hidden layers that contain the layers which are responsible for the convolutional part. In most cases, this will consist of a layer that carries out a dot product between the convolutional kernels with the input matrix of the layer. This is a pictorial representation of the architecture of CNN. So at first we are having this input layer, then the convolutional layer, and finally the pooling and output layers. So for this work, we have introduced a data set, and we have received this data set from Nainital, Kumaon, India. The Aryabhata Research Institute of Observational Sciences is a research organization that focuses on astronomy and solar physics. So we have gathered this data from them, and they have made some important contributions to the scientific community, most notably in the field of astrophysics, like star classification and all, gamma rays burst. In this article, the convolutional neural network is proposed to be trained by using an imagery dataset that is contributed by ARIES. We believe in sharing is caring, so we have made the dataset clearly available at this GitHub link. Anyone can have a look in this dataset and can carry forward this research. This is a glimpse of the dataset that we have with us. These are the galaxies that images are being taken by the ARIES in Nainital, and these are the stars which have been taken. So there is a significant difference between this imagery, which one can't distinguish with the naked eyes, but CNN can do so. So from this slide onwards, we will be talking about the results that we have reached out to in this paper. So for the results, we would be concluding the precision recall curve and the confusion matrix. So for SVM, that is the support vector machine, we have this kind of precision recall curve, and 606 instances of true true in the confusion matrix and 31 instances of false false. For random forest, we have 606 instances of true true, while 44 instances of false false. For KNN, that is the K nearest neighbor, we have 596 instances and 39 instances of both of them. Then we have 479 and 61 instances of both of them. For logistic regression, we have 551 instances of true true, while 59 instances of false false. For decision tree, we have 518 instances of true true, while 82 instances of false false. And finally, by making use of the convolutional neural network, the accuracy versus epoch and the loss versus epoch ratio is coming out something like this: that with the increase in the number of epochs, we are having less loss, while we are expecting more and more accuracy. So from this, it's very clear that using convolutional neural network, we can have an edge over this classification, in contrary to the classical machine learning algorithms. So these are some of the references which we made use of for preparing the manuscript. So this is all from my side. Thank you for allowing us to present the paper. I'm open to your queries.
No question from my side as of now.
Thank you, ma'am.